Okay, as you all can see by the substitute and the fact that I'm not there, I'm not here today. I'm actually been pulled out for a meeting, but that doesn't mean we get to have a free day. Actually, the opposite. I want to make sure that we all understand the four-step inference toolbox needed for the chi-squared test for the goodness of fit, and also for the chi-squared test of association. So we're going to do that now. Get your notebooks out, get your calculators out, and get your AP packet out. Because what we're going to do is we're going to start with the problem that I showed you last class, and that's dealing with Trix, the cereal that is. And the fact is, I told you that 5 flavors with a different shape. We have 5 different flavors here: grape, lemon, lime, orange, and strawberry. Very important here, the fact that they are uniformly distributed. I'm going to take some of the work out for you. We opened up our box, we counted them out, we ended up with a total of 2,615 pieces. If they're uniformly distributed amongst 5, that'll be 20%. And if you take 20% of 2,615, you come up with 523. And those are going to be your expected values. But what I'm concerned about today is, one, that you can do the four-step inference toolbox correctly. I want to make sure, and I want to keep it a little bit simpler. I want to make sure it's similar to what we've done before. And 2, I want to show you how you can actually do all these calculations on the calculator. We're not going to use the test feature where we've been using the 1 sample, 2 sample. We're not going to use that feature, but I'm going to show you how we can do it pretty quickly using the stats. So what I want us to talk about first is step 1. And let's just, for keeping it simple, our population. We're still going to have a population and parameter. Let's just, to keep it simple, our population are all boxes of Trix cereal. This won't work for Lucky Charms or for Cheerios or anything else. This is only for Trix cereal. And our parameter is, are the boxes distributed correctly? So that's step 1. We're also going to have under step 1, as before, ho and ha. With a chi-squared test, ho and ha are all in words. And ho is always that it's correct. Ho is the box is correctly distributed. And ha being the box is not correctly distributed. Again, with a chi-squared goodness of fit, ho is always that it's correct. Step 2 starts off the same. SRS, with a chi-squared test, we need all expected values. All expected values must be greater than or equal to 5. And we just showed that they're all going to be 523. So let's put something next to it, like a check and a yes, something like that. And as we've done before, say what we're going to use. We're going to use a chi-squared goodness of fit test. And the way to remember this, we're testing to see if this is a good fit, if it's correctly distributed. So those are step 1 and 2. Not too much different than what we've done in the past. Step 3, here's the math I want you to do. Write chi-squared. The letter X is just the Greek letter chi. Chi-squared is equal to observed minus expected, the quantity squared over expected. This formula is on page 5 of your AP packet. This is what your step 3 is going to look like. We can put this. I'm going to show you how we can get this answer here using the calculator. And we're going to use the calculator to get this answer. So, pick up your trusty TI-84, turn it on, go to Stat, and let me get caught up with you. So you're going to turn on your calculator. And what I want you to do is put the observed values in L1. So everybody has these in here. We're halfway through our four-step inference toolbox. Here's what I want you to understand. This is observed. This is expected. Go all the way to the top of L3. And make sure you're all the way at the top. And while you're up there, what we need to type in is the following. Observed, which is L1, minus your expected, which is L2, that quantity squared, divided by L2. And it's going to do the math for you. This is what you want to add up. You want to add up this box here. And you can do it one of two ways. You can write down the values and add them up. Personally, I would rather do it a quicker way, and that's using the feature right here on your calculator, using list on our calculator. Let me show you how to do that. Second, quit to go to a main screen, and then we can go to second, stat, list, go over to math, and you have it right here, number 5, sum. And we're going to add up the sum of list 3. And we get 47.57. That's your chi-squared test statistic. 47.57 is exactly what goes here. 47.57. Now we had 5 colors. So our degree of freedom will still be -1. 5 minus 1 is now 4. Now pick up your AP packet and go to the back page, the very back page, page 15. There's your chi-squared test. We'll go down to degree of freedom of 4. You'll notice the first value I see is 5.39, then 5.99. I want you to scroll across till you find 47.57. And as you scroll across, you'll notice the biggest value you get is 20. And at 20, so this is more than 20. And at 20, we get a p-value of 0.0005. What does that mean for us? It means our p-value here will be less than 0.0005. Let's compare that to alpha of 0.05. Obviously, this value here is very small. Since our p-value is less than alpha at the 0.05, we're going to reject HO. And by rejecting HO, that means the box is not correctly distributed, and that's our step 4. Since p is less than alpha, 0.05, we reject HO and say the box is not correctly distributed. That's the 4-step procedure here. Step 1, population parameter, HO and HA. Step 2, SRS, expected values greater than or equal to 5, chi-squared goodness of fit. Step 3, you must show this formula. Show your, again, all you have to do is show your number. Degree of freedom is 4. Talk about what our p-value might be. It's extremely small, we reject HO. And then again, step 4, since the p-value we got is less than 0.05, we reject HO and say the box is not correctly distributed. That's all you have to do. Now, what I want you to try to do is this problem here. And this is one that we again started last time about Skittles coming in different colors. I want you to try to set up the 4-step inference toolbox here. There's twice as many blues as any other color. And again, we did this last time. We could say that's X, 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 and 2X for a total of 2, 3, 4, 5X. So if 5X equals 100, X equals 20. So that means we should have 20 here, 20% here, 20% here, 20% here, and 40% here. We can figure out the total, figure out our expected values, and I expect you to figure out the 4-step inference toolbox. We're going to get back together in a moment. I'm going to go through mine, and we'll see what you guys came up with. Good luck.